Ladies and gentlemen, hello and welcome, coming to you not quite live from One Take Studios, where we have a doozy of a lesson on our hands today. We're talking about transforming linear functions. And a lot of transformations are easier to work with because you can see what's happening a little bit better. And I find that with lines, it's a lot more difficult to see what's going on, thus resulting in a very abstract understanding of transformations, which I'm going to attempt to do my absolute best to explain to you. So we're talking linear, y equals mx plus b, and we've been playing with a, h, and k for transformations. And so each of these has a movement that it's associated with. If I kind of paired this up to my lovely slope-intercept form, I can see that, well, slope controls how steep a line is. What does a do? The same kind of thing. Stretches and compressions, it's going to control the steepness of the line. B doesn't have a direct equivalent because it would be some wonderful compilation of A and H and K all combined together, and so there's no clear y-intercept when I'm looking at it from this format. So, let's see what kind of damage we can do. We're going to take things one piece at a time. We are going to have the equation y equals x plus 6. This is going to be our parent function. This is where we are starting. And we're going to one by one work through each of these changes being made to this equation, thinking about what is going to be impacted. So vertical translation down 2. Well, based on what we've seen so far, vertical translation, K is what controls our up and down. So up and down. Can you see that okay? Not really. That's what it says, up and down. So K controls the up-down aspect of our equation. So if we'd like to go down by 2 units, we're going to take and we're going to down means subtraction, right? That seems logical. So we shall take our y equals x plus 6 and say we'd like to go down 2. That's our K value right there that we're kind of tacking on the end, which then of course we can and should simplify. So that gives us y equals x plus 4. That equation has been vertically translated down from y equals x plus 6. Doesn't seem super crazy. So what about a vertical stretch? Notice we're taking all the vertical movements at one time here. A vertical stretch. Vertical stretch. Vertical stretch. Ask yourself this. If I'm pulling things away from the x-axis, vertical stretch, should that impact my y-intercept? Hopefully you answered that with a yes. That means that I want to impact everything that's coming out of this function. I want to stretch all of it. What will that look like? Y equals, I want to triple everything coming out of the function, including the y-intercept. I'm tripling everything coming out of the function, including the y-intercept. If I simplify that, that would be y equals 3x plus 18. So what's the difference between that and a vertical compression? Again, vertical compression, squish, everything is going towards the x-axis, which again should impact my y-intercept. So in a similar manner, we've got y equals 1/3 because we are squishing things, and then we want to take 1/3 of everything coming out of this function, which includes the y-intercept. So that would be y equals 1/3 x plus 2 is the new function. That shows us a vertical compression with a factor of 1/3. I started there on purpose because those aren't super crazy. The next part is worse. Yay! Alright, so what's up next? All our horizontal changes. Boys and girls, here's the problem. Functions are set up in a y equals format. That means that we are always seeing things from y's perspective. Hence, all of these vertical transformations, make some sense. It is a lot more difficult to understand the horizontal changes when you are looking at things from y's point of view. For starters, if k is up and down, what is h? Tell me that you remember. What is h? Should be left and right. Why is there a negative sign there? That says x minus h. Why is there a negative sign there? Because a lot of people just accept it and go, because there's a negative sign there. Well, okay, maybe. Let me show you something different. All right, so we're pausing on the rest of this for a moment. Let's look at this. Let's say that I have, let's go y equals x for starters. And if I do y equals x, and let's go with a plus 8, plus 5. I like 5 better. That way it doesn't look like the rest of the numbers on this page right now. Plus 5. If I started with y equals x, and then I put the plus 5, I'm saying I'm taking this whole thing, and this should be k. This is moving up 5 units. I've just slid the entire equation, the entire line up 5 units. But I'm looking at it from y's perspective. Is there another perspective? Humor me for a moment. Let's rearrange this. Let's get the x by itself. Y minus 5 equals x. From x's perspective, we didn't increase 5. From x's perspective, we decreased by 5. So increasing our y values by 5, looking at it from y's perspective, happens to be the same as viewing a decrease of 5 from x's perspective. So what would appear to be positive in y's perception is actually a negative in x's point of view. So when I talk about a horizontal translation going to the right 2, going to the right is a positive movement. Yes, absolutely, for sure. However, because it's a horizontal change, because I'm changing the x, using a model that's written from y's perspective, everything's a little bit turned around. So if I take my equation here, again, we're working off of this guy. Maybe we give this guy bigger arrows so we can kind of see him a little bit better. There we go. Again, we're going back to this main function right here. I want to take this y equals x plus 6 and perform a horizontal translation going to the right 2. If I add 2 to this, that's not going to give me a horizontal translation. That's going to give me a vertical translation up 2. So instead, following this model, I've got y equals, what's happening to the x? Notice the x is in parentheses. I'm going to keep my x in parentheses. So here it is, right here. Here's my x. But if I want to go to the right 2, it actually is going to appear like I'm going to the left 2, because I am viewing this from y's perspective. In y's point of view, it looks like subtraction, but if you were to move the 2 to the other side, you would see that from x's perspective, it's actually a positive movement. So going to the right 2 requires us to have the negative in place for this to actually happen. No, I did not forget. We also had a plus 6 here. I'll put this guy in a box too. I don't like the way he's blending in with the rest of the page. There we go. Oops, bumped the camera. All right, so I have this. So my x has been reduced, deducted by 2. I still have the plus 6. That's it. So to the right, x minus h, right there, plus 6. Can I still simplify this? Absolutely. X plus 4 gives us the same effect of having moved my original line to the right by 2. What about a stretch? Factor of 3. Believe it or not, this might get worse for you right now. If I would like to multiply something by 3, well, let's start here, okay? Back to this land. Let's say that I've got x equals, and I'm taking 3 times all of my y values. From x's perspective, this would be a stretch of 3, because from x's perspective, I'm multiplying everything by 3. However, we are working with functions that are set as y equals. So what happens to this if I get the y by itself? Divide both sides by 3, y equals 1/3 x. Again, keeping y equals x as my original, what would appear from x's perspective to be a horizontal stretch with a factor of 3, from y's perspective actually looks like a compression when it's not. Again, everything that's horizontal, all horizontal changes are strange in some manner or another. If it's supposed to be adding, it's going to look like subtracting. If it's supposed to be 3, it's going to look like 1/3. Ooh, horizontal stretch. Horizontal stretch. If I'm taking and pulling something this way, should that change my y-intercept at all if I'm pulling things away from the y-axis? It should not. So here, when I had my vertical stretch with a factor of 3, I multiplied everything, including the y-intercept. This time I'm saying this change doesn't apply to the y-intercept. It only applies to the x. We're only changing the horizontal portion of things. So I take my lovely starter equation, I write my y, but again, I'm going to stick with the parentheses here because I think that it helps us to see what changes we're making to the x specifically. Even though we have a stretch factor of 3, from y's perspective, this is going to show up as a 1/3 x. And we still have plus 6, and this is going to be unchanged because we are not changing the y-intercept when we are stretching horizontally. And if I just want to write that as y equals 1/3 x plus 6, I can do that. I don't absolutely need the parentheses. Like I said, I just kind of like them because it shows that I'm changing the x's. So horizontal things change x's. Horizontal things change x's, not y-intercepts. Okay, can you make this leap? If a horizontal stretch with a factor of 3 appears as 1/3, if I'm doing a horizontal compression by a factor of 1/3, because it's a change to the horizontal, but we are working from y's perspective, 1/3 will look like what? Think about what happened here. This is saying y equals, again we are changing the x's and the x's only, this is going to be 3x plus 6. Horizontal change of 1/3. This is actually a compression. This is a compression by a factor of 1/3, but it looks like 3x because we are changing the x's from y's perspective. We have the y by itself. Again, I can write this as y equals 3x plus 6 and call it good. I'm going to do one more example with you. I'm going to tell you right now, you're probably uncomfortable with this. That's normal. Cut yourself some slack. When you're trying to figure this out, give yourself some learning time. Do the best you can and learn from your mistakes. Because with this, honestly, it just takes some time for it to sit well in your brain. It's not going to sit well in your brain right away. Okay, let's see what damage we can do here. Here's my last example. Put multiple eggs in the same basket. F of x equals 3x. All right, this is completely different from everything we got going on top here. We're using a whole new starter equation. F of x equals 3x. And we're going to do 2 transformations to this puppy. So we're going to move it 6 to the left, and then we're going to stretch it horizontally by a factor of 4. The and then is important because it tells us which one to start with and then which one to go to second. So we're going to begin by moving it 6 to the left. Pause. To the left. Think. That's a horizontal movement. Horizontal movements impact the x. So watch this, okay? Watch this quite carefully. We are saying, I've got my f of x. You could write y if you wanted to. That would be fine. The 3 is not part of the x. The 3 is a coefficient. If I'm going 6 to the left, go back to this model. That 3 is my a on the outside. Here's my left-right movement. It's happening in the parentheses with the x. I am only changing the x when I'm doing horizontal changes. And if I'm going to go 6 to the left, 6 to the left, 6 to the left, again, it's a horizontal change. It's going to appear to be reversed. So moving to the left, which would normally be a negative thing, is actually plus 6. That is our first change. Change number 1. Change number 1. Can I simplify that? Yes. Should I simplify that? Yes. So f of x is now going to equal 3x, and yes, you should distribute, plus 18. Now we have our second change. Now we can work on our second change. So this becomes our new equation we're working with. We're going to forget the rest of this. We've already done our first change. We would like to stretch this horizontally by a factor of 4. Again, I am picking the things that are more difficult right now because I think that's what you're going to be needing to see the most. So we are stretching horizontally. Horizontal changes happen to the x and only the x. Horizontal changes, stretches and compressions, don't impact the y-intercept at all. So f of x equals 3. I'm going to use my parentheses again to show that we are changing the x, but I'm going to leave the 18 as an 18 because the 18, the y-intercept, will not be changed by a horizontal stretch. If it's a horizontal stretch by a factor of 4, it's a horizontal change. Once again, it's weird, it's messed up, it's backwards. Instead of multiplying by 4, it's going to appear, because we're looking at everything from y's perspective, to be a 1/4 fourth x, showing that we are just putting our multiplier here with the x to create the horizontal change. Can I simplify this? Yeah, I can. So f of x is equal to 3 times 1/4. You are correct. That is 3/4. 3/4 x plus 18. Ladies and gentlemen, that is the final equation, starting with this as my parent function and creating these changes to make a new equation. Again, like I said, cut yourself some slack. This doesn't sit well with most people on the first try. Give it your best shot and practice, 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 and get some feedback along the way, okay? All right, thanks.